Hey, welcome back to our last movie, Chapter 9, Iterative Solutions. This is, like I said, Chapter 9 in the book, and what we're going to learn here is how to use some of Excel's built-in functions to solve equations. Sometimes that process is known as root finding. All right, in this first direct worksheet, what we're going to do is use a process known as guess and check to find the solution to an equation. Now, if you look up here in the top left, the equation that we're trying to solve is 0 equals ax cubed plus bx squared plus cx plus d. All right, over here in the coefficients, I have made name cells A, B, C underline, and D. Now, for some reason, Excel wouldn't take just plain C. It went to column C, so I had to put an underline. If you have trouble naming things just plain old A, you may have to put A underline when you make it. In any event, what we do is, for this guess and check method, is to solve this equation for x. Now, we're going to come down here and we get a solution for x, which is in the cell B7. Now, you look at that algebraically and you say, wow, how do you solve for x when x is on two sides of the equation? Well, analytically, this doesn't look like a good way to solve for x. But with the guess and check method, this is what we need. We need x on one side of the equation and all the other stuff, including perhaps some functions of x on the other side. But as long as we have an x to the first power on one side with no coefficients, we're good to go. That's known as a standard form. Alrighty, so how does this thing work? Well, we're trying to find the roots. The roots are the values of x that make this equation right up here equal to 0. And if you have something to the third power, you can have up to 3 real roots. So let's see if we can find some of those roots using the guess and check method. So let's come down here and we're going to set up a little chart right here, and we're going to make an initial guess right here in C11. I just typed that in, minus 4.5. How did I know to put minus 4.5? You're going to see on the next spreadsheet. Okay, let me just go to it. This goal seek, where we use similar values. Okay, and I found that there were solutions around minus 4.5, about 0.7, and maybe 3.5. So I have my initial guesses based on a graph that I had previously made. Okay, so there's minus 4.5. I'm going to take a look for one of the roots there. Okay, so we're going to make two columns down here. One called xg, which is x guess, and the xc is going to be the x check. Okay, so the first x guess is just going to be this minus 4.5, which is $C $11. All right, so I want that locked. Okay, so that's our first guess as to what the solution is. Now, we then check it with this equation, which is the second standard form. Okay, notice that x is equal to ax cubed plus d divided by minus c. All right, so there's my formula for finding the new value of x. Okay, so I put OK. So once I get the first guess, I then use that guess to find a better checked value. Then I'm going to go to the next line. And this is why it's called iterative solution. Iterative means repeat over and over again. So now I'm going to take the x check value and make that my new x guess. See this equal B13. All right, and then we're just going to then use this new guess value to get a new check value. Once you get these first two columns done, you can just drag down and get the rest of these. Okay. Now, if things converge, then you should see these x guess and x check values not changing very much as we go down. But as you can see, uh, they get more and more spread out. So this we say that the value of x has diverged, and we have not found a root to our function. I'm going to do the exact same thing over here using an initial guess of 0.5. When I do that, I'm going to come down. In fact, you can probably copy a lot of this over. But I do find a root at 0.72. Finally, I try a guess at 4.5 positive, and once again I get this divergence. Look where this diverges to, 1 times 10 to the 43rd power. So the direct substitution method, which is also known as guess and check, does not always work. Let's see what we get if we try a different technique. All right. So what I'm going to do for this second technique is I'm going to use the same formula up here that I have been using. Okay. So C22. Wait a minute. C22 is the cell itself. Wow. Usually you can't do this in Excel. You can't use a cell reference of the cell you're writing the formula in. This is oftentimes called a circular reference. Well, let's see about that. I'm going to go to Options. I'm going to go to Formulas. Enable Iterative Calculation. So usually when you do this, okay, that's going to be off and I get a value. But when you do this, you're going to have this off, and you're going to get this message if you try to put this formula in. It's going to say there's one or more circular references. Circular references mean in your formula you're using the cell that the formula is contained in. Okay, as you can see here, we're writing the formula in C22, yet we're using the value of C22 in the formula. Excel usually does not accept that. It says no go, don't like it, no. Okay, so how do you get around that? Well, you override Excel's natural instincts by going to File, Options. You go to Formulas, and there's a thing here called Enable Iterative Calculation. And what that means is you are allowed to use the value of that cell in the formula of that cell. And what this says is it's going to, if you do that, it's going to repeat the calculation 100 times or until there's a maximum change of 0.001. Okay? So I just did that and it came up with my answer. So activate iteration by file. It's actually Options now, Formulas. Okay, so that's kind of, this spreadsheet here is kind of a manual way of doing some things that you're going to see Excel will do automatic. All this guess, check, guess, check, guess, check. Okay, Excel has a few ways to do that, and one way is in the second spreadsheet known as Goal Seek, and this Goal Seek one is on pages 368 to 370 of your book. I've got the same function that I just used on the direct worksheet, and this time it's always a good idea to plot out some values in a table. And a table can actually tell you approximate locations of the roots. Anytime there's a sign change in your function, that means that a root or the value of 0 must have occurred somewhere between those two values. So it says between -4 and -5 I had a sign change, and if I look on the graph between -5 and -4, indeed I went from negative values to positive. So that means there must be a root between -4 and -5. Likewise, between 0 and 1 there's a sign change, and between 3 and 4. Okay. So that brings us down to, once we have an approximate location where the roots are, then we can use this thing called Goal Seek. But I'm going to just tell you, it's always highly recommended that you make a graph and a table of your function so you can take a look at where the approximate roots are, so you know approximately where you're looking for these things, because goal seek is going to require an initial guess. So I want you to type in this stuff, first of all the headings, and then you're going to type in the -4, -0.5, and 3.5, and then you're just going to copy that over here. So the initial guess and the goal seek solution will be one and the same. Okay, now what we're trying to do is we have the value of the function right here. Okay, so I'm using the value of x right there in the goal seek. The other variables I'm using from my coefficient table up there. They're named variables. Okay, so this initial column over here, I'm just reminding ourselves that that's what we initially had in the goal seek column. Now watch the magic here. Okay, now what we could do is we could change these values, -4.5 and try -4.4, see if that comes up with something closer to function equal to 0. Or I can just go to, let's see, I think it's home, maybe it's in formulas, and maybe it's in data. What if? Okay, here's what if analysis. Whoops, I was in a formula, I got to get out of it. Okay, there's what if, it's just in my data thing. All right, so what we're going to do is we click on what if. We've used this once before. Goal seek, this pops up. I'm going to bring this right down over here. So we're going to set cell F29. So this is the value of our function. We want to set it to a value of 0, right? We want to find out what the value of x is that makes the function equal to 0. So we're trying that. And we're going to change our value of x, which initially is going to be our guess value. All right? You do that. You put OK, it does a big iteration, and it comes up with a solution of -4.43, which looks pretty close. And then the value of the function when you use x equal -4.43 is -6.5 times 10 to the -5th. So it doesn't get you exactly to 0, but it gets pretty close. Now sometimes you can run the what if again, all right, and use your new value we just found as our new guess, and sometimes you can converge a little bit more, but it doesn't look like that's the case here. So that's the best Excel can do for us. All right, now these other two, you're going to do the same darn thing, but you want to start with the initial guess in the goal seek solution. So I'm going to do one more just to make sure you have it, and then I'll leave the last one for you. You do goal seek. So this time I want to set this cell, okay, which is still that same function, to a value of 0 by changing this one here. And I put OK, and it comes up with another solution, and we get pretty close to 0. So just to remind you, this f of x column, you're just using the adjacent value in the cell. Okay, so you can do this once and then just pull these down. And in fact, I'll just do it. Okay, but initially I want you to start out with these guess values and the goal seek solution to be one and the same. All right, so that's goal seek. A very similar but much more powerful tool that can do the same kind of thing is solver. Okay, so this is a little different coefficients from the last one, and I get some different places for sign change, and I set up the sheet the same way. But instead of using goal seek, I'm going to use this tool up here called solver. Now if in this analysis tab, which comes under data, you don't have a solver, then you're going to have to add it in. Okay, let's remind us what we do. We do file, we do options, you click on add-ins, you find solver right here, you'd put go, it'd come up, you'd want to make sure that I already did analysis tool pack, I'm going to put solver, I put OK, and now I've got solver. And solver is going to work similarly to goal seek in this application here. First off, we do the table, we see where the sign changes are, we graph this out, so we can see that we've got some roots at between -4 and -3, about equal to 0, and then 5 to 6. I put my 3 guesses down here. I didn't put 0 because I know the solution's 0, but I just put a 0.5 so you can see that's going to change. All right, so I've got our formula there, and now I just come up here and hit solver. I hit solver and it doesn't like something. Okay, it's because I was in a formula cell and I messed it up. So I'm going to hit undo. Okay. So now that I'm not in the formula bar, I hit solver. Okay. So I'm going to set cell. Let's get this up here. F29, that's the value of the function, to a value of 0 by changing this cell right here, the E29. Now, it used to be Excel had this checked, make unconstrained variables non-negative. What happens is you could never find negative roots unless you knew to unclick that. Thankfully, in 2016, they took the check mark off of this. So you hit solve, bam, it comes up here. You want to keep the solution. I put OK. So there's our first solution. You do the same thing with solver on the next two, and you get your values for me. Okay? Let's go to min-max. All right, got a similar function here. I graph it out. Now, in this case, instead of finding the roots, by the way, min-max is, well, I've gone further ahead here. Min-max is in the book. I've changed it a little bit. It's on 378 to 382 if you're following along. And what we want to do is find where does this relative maximum and this relative minimum occur at? All right. And this is where we're going to use solver to find these mins and maxes, or at least the localized mins and maxes. Okay. So we're going to use something called the constraints. Okay. So I'm going to set up my sheet like this. I'm going to type all this stuff in. I'm going to type in relative max. My initial guess, -3, you're going to type this in, okay, x less than or equal to. 0 is something I'm going to type in, x greater than or equal to -4. So I'm telling Excel, hey, only look between 0 and -4 for this maximum. Because if I didn't put that in, it'd find a maximum way over here greater than 6 because this function starts going up. All right, so I gave it a constraint where to look. Then I put an initial guess solution. Okay, so initially I want you to put -3 and 3 in here. Okay, all right, now this cell is the function itself. Okay, and use these up here. Okay, I click off of this. I know I have to do that. So I'm saying, okay, somewhere's around -3. Let's see if you can find me the maximum. Go over here to solver, and I do the cell. I'm going to set I29 to a maximum by changing this one, the I29, subject to these constraints. Now let me just show you how to type these constraints in. Okay, since you would be starting here with neither of these, okay, I'm just going to delete that one and delete this one. All right. So if you need to add a constraint, you just go over here, add. All right. So cell reference. Okay. So what we're going to do is we're going to say the value for our solution right here, x. All right. We want to make sure that that's less than or equal to 0. Okay. I can actually just click on the cell there, and I'm going to put add. All right. So that was one thing. Now the other thing I want to do is make cell I29, I want to make sure it's greater than or equal to, so I do this, greater than or equal to -4. Okay, and I'll put the constraint there. And I'll put add, and then I put OK. Cell reference box, I just put OK, so I'll cancel that one. All right, so I've got two of them. I want my value of x, which is an I29. I want it less than or equal to 0, which is F29, and I want it greater than or equal to H29, which is -4. All right, so I've got those two constraints that say where to look for the value of x that creates a maximum. I hit solve, and bam, I got a solution at -2. And the value of the function is 12 there. Okay, so there's my maximum. Now to get the minimum, you're going to do a similar thing. We're going to say, hey, let's guess that it's about 3. And I want you to use these constraints. So I'm going to leave that up to you. So same as what I just showed you, but you're going to exchange a minimum for a maximum. All right, the IRR, you don't have to do this thing. In previous years, students had to do financial worksheets as well. That's Chapter 8 if you want to go back and do it. We skipped it this year. Let's go on over to vapor. Let's see what's happening there. That's between 383 and 387. Okay, in this case, I've got a function with A, B, and C variables. Okay, I've got a predicted value, this y predicted, which is A minus B divided by C plus T. Okay, so this is the function right here that I'm trying to fit this data with. Okay, so I've got a temperature, I've got a pressure, I've got log of P. So now log of P is going to be my y variable, and then I have a predicted value for the log of the pressure. Okay, so there's my values. So I've used name cells up here and just copied that all the way down. Okay, I have a line here because I had to hide some cells. But what happens here with Excel, let's see, if I hide cells, let's just keep going. All right, watch what happens. I right click, I hide. All right, what happens is it hides anything that's hidden doesn't get graphed. So that doesn't do me any good. So eventually I'm going to have to unhide these. Okay, but for now, I can at least show you some things. All right, so you're going to get a predicted column. You're going to get an error column. Error column is simply going to be your value of y minus the predicted value. So this is also known as a residual. We talked about that before. The error squared, that's just error squared, raised caret 2. Okay? Now, I don't know why it did that to me, but you do something you don't know, you just hit undo a couple times, we're back to good. All right, then I'm going to get the squares. Okay? Now I'm going to get a value of y average. Let's show you that. This average y. So I just took the average of all these y values and put it in that cell, and I called that y_av. So in the squares, I just took my value of y minus my y_av and squared that whole quantity, and then down here I get two cells, one I named SSE, which means sum of the squares of the errors. Okay, so this is the error square, so that's my sum of error squared. Okay, so sum of that column. All right, then I have a second sum right over here, which is called SST. It's called sum of the squares total. All right, so you get all those. Okay, now the way you get the r squared value, which is a measure of how good you're fitting your data, it's 1 minus this quantity SSE over SST. So right now, we've got a pretty bad fit, as you can see here with the original y and the predicted. Okay, the y is blue, the y predicted is red. It just doesn't look good at all. Okay, one of the reasons is because I've hidden a bunch of stuff. So let's unhide this. Okay. Alrighty, now to get a good fit, what you're really trying to do is you're trying to minimize the sum of the squares error. Okay, because remember what that is. It's how much your predicted equation diverges from the actual value. Now, why are the errors squared? Because notice that some of the errors are positive and some are negative. Well, most of them are positive, but these errors can be positive or negative. So if you just add up this column, a negative error and a positive error end up canceling, which is not really what you want to do. So in statistics, they use the square so you don't get that cancellation. Alrighty, but anyway, what we're going to try to do is find out what are the best values of A, B, and C so that this predicted formula right here will get us closest to the values of y. And that's going to be measured by how small we can get SSE. All right. So let's come down here. I'm on SSE. I want to minimize that by changing the values of A, B, and C. Now, initially A, B, and C, I want you to start them at 1. Okay. So we're going to go to Solver right here. And I want to set this cell SSE. Okay, it already popped in because I did this, but if I click on it, it says F52. Okay. I don't know why it didn't say SSE there anymore. I want to set that to a minimum by changing, okay, by changing these three cells, A, B, and C. Okay, those are our final solutions. I'm not going to subject it to any constraints, although I could. So now what Solver is going to do when I hit solve, it's going to mess around and change these values in A, B, and C until it can find the smallest possible SSE. So let's hit solve. And it says we have a solution. I put OK. Well, look, the SSE went down to 0.0006 and the R squared value went to 0.99981. So, and then if we graphically look at this, okay, and you're going to have to plot log P versus temperature with both your experimental data y and your predicted, and you can see the red line goes through the data nicely there. If you put your predicted versus your original, you should get a slope exactly equal to 1. Put a trend line in there. The closer that slope is to 1, the better. And then I want you to make a line graph of the errors. Okay. This is one of the few times you're going to use a line graph, and let me just right click, change chart type, and actually I did a line graph. What a line graph does is just put equal spacing between all the data points. So these data points are just these errors right here. Okay, so you're going to make these three graphs, and you're going to run the solver. I'm not going to show you up at the top what the values of A, B, and C are. I'm going to leave that for you to find, but you should get a pretty good fit. Let's move over here to linear. Okay. Here we're getting another demonstration of just how powerful the solver is. So we have an equation right in this cell, x1, x2. The goal here is, our objective is to find the minimum of this equation. Okay, so you're going to name cells x1 and x2. I had to put underlines because x2 also refers to a cell. So initially you're going to make sure that these initial guesses are the same. You're just going to copy those into the final solver solution. All right, so I've got all these constraints that x1 and x2 have to be subject to, and this equation. All right, so you're going to pull up solver. No, not that one. It's solver. Okay, and I've got it all done here, so I'll just show you this. So we want to set the objective cell, which is E5 right there, to a minimum by changing these two, the x1 and x2. Subject to, okay, now you're subject to, now when you talk about this x1, it's really the E9 square, okay? So for instance, if I wanted to make sure that x1 was greater than or equal to 4, okay, so right now it's just what is the current value. These are initial guess values over here. Okay, E10, I don't want that. Okay, I'm going to be changing these two cells. All right, so I put all the constraints in, greater than equal, and I used these cells. Notice I didn't type in any constants, so I'm not going to go through all the painstaking thing of putting those in, but you know, you hit add and you put them in. If I hit solve here, okay, I'm going to get a solution. And I'm going to leave that up to you so that you actually do it and don't type it in. Okay. Okay, next we're going to move to iterative, which is a problem that you're going to solve. And once again, you're going to do this a lot like you did the goal sequence solver. I want you to do a table. I want you to do a graph. And there's only going to be one root here. You can see it's between 1 and 1.5. So I want you to use solver here and make sure you put initial guess in somewhere in this range. And then I want you to actually run solver. Then you get the last one is the problem regression. Now right now I have not optimized the values of A and B, but and you only have to do one graph here, which is this one. Once you solve for these solutions, in fact I'm going to do that and show you what the final result is. But down at the very bottom I have SSE. Okay, so I'm going to do solver. I want to take my SSE value right there to a minimum. How am I going to change it? By, whoops, gotta be careful where you're clicking. Okay, so I want to make that subject to changing A and B right there. I'm going to scroll down so you don't see the solution. I'm going to hit solve. There's a problem with the formula, not trying to type a formula. Okay. Objective must be a single cell. Okay, got it. Got it. Close. Okay, it's really unhappy here. Can you believe this? Help. Objective cell must be a single. Oh, sorry. Set objective. Hopefully that was the only problem. I just want that by changing D4 and D5. Let's give it a try. Solve. Says it found a solution. Let's take a look at the graph. Does it look like it did it? Yeah. So there's my solution in red. I'm not going to show you what the values of A and B that did that are. I want to leave that to you. Hey, we finished Excel. There's a whole bunch more chapters to go, but we've run out of time, and we're going to get over to LabVIEW in our next segment of the course. So see you later. John Waddick, your Excel guide, is saying au revoir.